At 0320 am, the night sky over the Ust-Luga energy complex in Leningrad Oblast was ripped apart by a detonation so violent it registered on seismographs in neighboring Finland. A single Ukrainian Lyutyy drone, a slow-moving assembly of fiberglass and plastic costing less than a family car, had just navigated 1,000 kilometers through the world's most heavily defended airspace to deliver a fatal strike on Russia's economic heart. As the massive Novatek gas fractionation towers melted into twisted steel under a 1000-degree chemical inferno, the myth of the invincible S-400 air defense system evaporated along with millions of dollars in export. The Kremlin woke up to a strategic nightmare. If a cheap propeller-driven toy can humiliate a nuclear superpower's elite defenses deep in the rear, is the era of Russia's energy dominance burning to the ground? To fully grasp the magnitude of the Ust-Luga strike, we must look beyond the immediate destruction and analyze the strategic geography of the Baltic energy corridor. The Ust-Luga complex is not merely a commercial port. It is the jugular vein of the Russian Federation's hydrocarbon economy. Located nearly 1,000 kilometers north of the Ukrainian border, deep within the Leningrad Oblast, this sprawling facility processes stable gas condensate into high-value naphtha, kerosene, and diesel commodities that generate the critical petrodollars, essential for funding the Kremlin's war machine. For nearly 2 years of full-scale conflict, Moscow operated under the comfortable assumption that this vital economic engine was geographically immune. The strategic logic was rooted in distance. Ukraine lacked the long-range missiles to strike this far north, and the region was theoretically shielded by the Western military district's overlapping anti-access area denial, a 2 AD bubbles designed specifically to counter high-tech NATO aviation, not improvised drones. However, as the ground war in the Donbass and Zaporizhia devolved into a grinding stalemate of trench warfare and minefields, the strategic calculus in Kyiv underwent a radical transformation. Ukrainian military planners initiated a doctrine of asymmetric economic strangulation. The objective shifted from solely destroying armored vehicles on the contact line to dismantling the financial and logistical infrastructure that sustains them. By targeting downstream energy processing facilities, Ukraine aims to inflict a cost imposition strategy on Russia, forcing the general staff into a nightmare scenario of resource allocation. The sheer distance involved in this operation, traversing nearly 1,000 kilometers of hostile territory, meant bypassing layers of electronic warfare and radar coverage that were previously thought to be impenetrable. The strike proved that the concept of a safe rear area is now obsolete. This creates a paralyzing dilemma for the Russian command structure, which must now decide where to deploy its finite supply of Pantsir and Tor missile systems. The obvious question facing the Kremlin generals is brutal. If you cannot defend everything, what do you choose to sacrifice first? The air cover for your troops on the front lines, or the multi-billion-dollar refineries that pay their ammunition? The successful incineration of the Ust-Luga terminal was not a lucky shot. It was the culmination of a weeks-long, high-stakes intelligence operation orchestrated by Ukraine's security service SBU and military intelligence GUR. While the world watched, the static front lines in the South Ukrainian mission planners were conducting a forensic analysis of Russia's deep rear air defense architecture. Utilizing a fusion of commercial synthetic aperture radar, SAR satellite imagery, and high-risk human intelligence (HUMINT) from assets inside Russia, they mapped the precise engagement envelopes of every known S-400, Pantsir S, one battery protecting the Leningrad Oblast. They weren't looking for the strength of the Russian shield. They were hunting for the cracks between the plates. The weapon chosen to exploit these gaps was the indigenous Lyutyy Fierce long-range drone, a platform that deceptively resembles a twin-boom hobbyist aircraft but is in reality a sophisticated loitering munition capable of autonomous waypoint navigation over 1,000 kilometers. The genius of the operation lay in the flight programming. Unlike a ballistic missile that follows a predictable parabolic arc, which radars can easily track and intercept, the Lyutyy drones were programmed with a complex, non-linear flight profile. Ukrainian engineers spent sleepless nights in secret workshops calculating fuel burn rates against headwinds to design a zigzagging route that skirted the edges of Russian radar coverage. They utilized terrain masking, programming the drones to hug the treetops and follow river valleys, effectively using the curvature of the earth and ground clutter to hide from the formidable gaze of the Russian 92 N6E gravestone radars. It was a technological gamble that pitted agile, low-cost innovation against heavy doctrinal rigidity. The Ukrainian team was betting everything on a psychological flaw in the Russian defense complacency. They calculated that bored radar operators sitting in a safe zone far from the war would likely dismiss a faint, intermittent blip moving at 150 kilometers per hour as a flock of birds or a weather anomaly rather than an inbound threat. But as the drones silently crossed the border, the question remained, had the Russians finally woken up, or was the back door to St. Petersburg still wide open? The final phase of the operation began not with a roar, but with a low, menacing hum that drifted off the freezing waters of the Gulf of Finland. For 6 agonizing hours, the swarm of Ukrainian drones had navigated a labyrinth of electronic silence, threading the needle between the engagement envelopes of the Western Military District. Flying at a perilously low altitude of just 20 meters above the waves, the Lyutyy drones were effectively operating in the sea clutter, a chaotic zone where radar waves bounce off the water's surface, creating enough digital noise to mask a small composite airframe. As they approached the terminal phase, the onboard flight computers executed a pre-programmed pop-up maneuver, climbing rapidly from the deck to acquisition altitude. This was the moment of maximum vulnerability, the instant where stealth was traded for target acquisition. On the ground, the serenity of the Ust-Luga complex, illuminated by the industrial glow of floodlights, was about to be shattered by the physics of kinetic warfare. Inside the command vehicle of a Pantsir S-1 battery stationed near the perimeter, the radar scope suddenly bloomed with confusing data. The operator was staring at a nightmare scenario, multiple slow-moving targets appearing out of nowhere deep inside a zone that was supposed to be secure. The S-400 Triumph system stationed further inland, designed to track Mach 4 missiles and high-altitude fighters, had effectively filtered out the drones because their low speed fell below the velocity gate used to ignore birds and cars. By the time the short-range air defense radars achieved a solid track, the geometry of the engagement was already hopeless. The drones were not just approaching, they were already in their terminal dives. The operator frantically switched to optical tracking, his hands flying across the console to slew the 30mm cannons, but the reaction time of the human loop was simply too slow for the unfolding catastrophe. He wasn't fighting a pilot who feared death, he was fighting a machine programmed to die. At 0320 AM, the first drone announced its arrival, with the terrifying distinct sound of a lawnmower engine screaming at maximum RPM. Port workers on the night shift looked up in confusion, freezing as the winged silhouette passed directly overhead, ignoring the panicked shouts of security personnel. The drone slammed into the primary gas fractionation tower with surgical precision. The warhead didn't just detonate. It ruptured the high-pressure containment vessels, releasing a massive cloud of superheated gas condensate that instantly ignited. The resulting explosion was a BLEVE, a boiling liquid expanding vapor explosion that engulfed the facility in a fireball visible for 50 kilometers. But the nightmare was choreographed. As emergency sirens wailed and fire crews rushed toward the Inferno, the second and third drones arrived, striking adjacent processing units to ensure the fire could not be contained. The double-tap strike turned the facility into a self-sustaining furnace, feeding on the very fuel it was meant to export. The air defense batteries finally opened fire, sending tracers blindly into the smoke-filled sky, but they were shooting at ghosts. The damage was done, and the most heavily defended energy hub in Russia was burning out of control. In a swarm attack, the most dangerous variable isn't the size of the warhead, but the precision of the impact point. And the obvious question is, how can you defend a static target when the enemy can choose the exact second of your destruction? The immediate aftermath of the impact was a masterclass in chaotic futility. Minutes after the first detonation, the Pantsir S-1 battery stationed on the perimeter finally slewed their turrets, unleashing a desperate barrage of 30mm tracer fire and 57 E-6 interceptor missiles into the smoke-choked sky. But they were effectively shooting at phantoms. The engagement radar, designed to lock onto high-speed threats like cruise missiles or fighter jets, struggled to maintain a track on the remaining composite drones amidst the intense thermal blooming of the burning refinery. The heat signature from the Inferno was so massive, it blinded the infrared sensors, creating a thermal wall that masked any further inbound threats. On the ground, the situation devolved into absolute bedlam. Emergency crews attempting to battle the blaze found themselves fighting a losing war against physics. Attempting to douse a high-pressure condensate fire with water is akin to trying to put out a grease fire with a flamethrower. This failure exposes a critical vulnerability in the Russian defensive doctrine known as the coverage gap. While the S-400 provides a massive 400-kilometer denial bubble, it cannot look down. To see a drone flying at treetop level, you need a line-of-sight radar every 20 kilometers, a logistical impossibility for the largest country on Earth. The Russian General Staff is now trapped in a zero-sum game to protect these rear-area energy hubs. They must strip air defense assets from the front lines in Ukraine, leaving their tanks and artillery naked to HIMARS strikes. They have plenty of missiles, but they simply ran out of geography. The question is, what happens when the enemy realizes that your shield has a million tiny holes? The incineration of the Ust-Luga terminal represents a masterclass in the ruthless mathematics of asymmetric cost exchange. To understand why this strike is so revolutionary, we have to look at the financial disparity between the weapon and the target. The Ukrainian Lyutyy drone is effectively a low-tech fiberglass airframe, powered by a generic internal combustion engine, with a unit cost estimated between $30,000 and $50,000. In stark contrast, the Novatek gas fractionation tower it destroyed is a bespoke industrial asset, worth hundreds of millions of dollars with a replacement timeline measured in years due to Western sanctions on high-tech components. This is not just combat, it is an economic siege where the attacker pays pennies to inflict billions in damage. Technically, the success of the strike exposes a critical flaw in the logic of modern air defense, the velocity gate problem. The Russian S-400 Triumph is designed to track hypersonic missiles and Mark II fighter jets. To function effectively, its fire control radar uses Doppler filters to ignore slow-moving objects, ensuring the operator's screen isn't cluttered by flocks of birds, highway traffic, or wind-blown debris. Ukrainian engineers exploited this algorithmic blind spot by programming the drones to fly at speeds that mimic biological noise, effectively allowing them to hide in plain sight within the radar's rejection threshold. Furthermore, the use of composite materials in the drone's fuselage drastically reduces its radar cross-section RCS, making it appear no larger than a seagull to older search radars. But the most dangerous aspect is the shift toward saturation tactics. A Pantsir S-1 system has a finite number of engagement channels. It can only track and engage 4 targets simultaneously. If you launch a swarm of 5 cheap drones, the laws of mathematics dictate that one must penetrate the shield. Ukraine has realized they don't need to destroy the Russian air defense network. They simply need to mathematically overwhelm its processing capacity. This signifies a doctrinal pivot from quality over quantity to quantity as a quality all its own. The terrifying implication is that the defense has to be successful 100% of the time, while the cheap drone only needs to be lucky once. If the standard for air superiority has shifted from jet fighters to flying lawnmowers, the aftershocks of the Ust-Luga strike radiated far beyond the smoking ruins of the terminal, triggering a strategic crisis within the Kremlin that disrupted the very geometry of the war. In the immediate aftermath, satellite imagery confirmed a frantic redeployment of air defense assets, with S-300 and S-400 batteries being pulled from the occupied territories in southern Ukraine to reinforce the vulnerability of St. Petersburg and the Leningrad Oblast. This is precisely the strategic dilemma Kyiv intended to create. By threatening the economic rear, they forced Russia to thin its defensive line on the front. Every Pantsir system moved to protect a gas plant is one less system protecting a tank battalion in the Donbass from GMLRS strikes. The economic impact was equally severe. Bloomberg reported that naphtha exports from the terminal dropped by nearly 35% in the weeks following the attack, choking off a critical stream of foreign currency just as the ruble began to wobble. But the most profound damage was psychological. For 2 years, the residents of St. Petersburg lived under the illusion that the special military operation was a distant colonial conflict, something to be watched on television but never felt. The Ust-Luga Inferno incinerated that social contract. It brought the visceral reality of total war to the doorsteps of Russia's second capital, proving that the Federal Security Service (FSB) could no longer guarantee the safety of the homeland. The airspace closure over Pulkovo Airport, triggered by the drone swarm, signaled to the Russian elite that their sanctuary was an illusion. The war has metastasized from a localized border conflict into a relentless campaign of attrition where the front line is everywhere. If the enemy can turn your primary source of national revenue into a burning liability, how long can you sustain a war of aggression before your own economy collapses under the weight of its own defense? The strike on Ust-Luga stands as a defining moment in 21st century warfare, marking the end of the era where distance equated to safety. It demonstrated that a nation does not need a trillion-dollar air force to cripple a superpower. It only needs ingenuity, intelligence, and a swarm of cheap, disposable machines. The burning fractionation towers serve as a grim monument to the obsolescence of legacy military thinking, proving that in a connected world, critical infrastructure is only as secure as the enemy's willingness to destroy it. We are witnessing the democratization of strategic bombing, where the barrier to entry for devastating long-range strikes has collapsed from billions to thousands of dollars. Russia learned a hard lesson in the snow. That night, in modern asymmetric warfare, you can have the strongest army in the world and still bleed to death from 1,000 paper cuts. As we move forward, the question is no longer about who has the better missiles, but who can sustain the economic pain of a war that knows no borders. If you want to understand the terrifying future of autonomous warfare and how it will reshape global security, make sure to hit that subscribe button and turn on notifications. We will be breaking down the technical specs of the new Lyutyy drone generation in our next deep dive. Bye for now.